One of my favorite things about my job is the fact that I have access to leaders in the industry. I'm talking about the firearms industry. Today, we're going to be talking to the folks at MK Machining. These guys are hardcore innovators in the space of additive and other types of manufacturing. Specifically, you're going to find products from MK Machining that you're going to be able to buy, like their scope accessories, their grips, etc. You'll also purchase products that are manufactured by MK Machining for the industry, and then if you are developing a product, they can help you take that product to market and do everything from design to manufacturing to post processing for specialty products. So, what I want to start with is an introduction with their team. Well, thank you guys for joining me.
You're very welcome.
So, MK Machining is a company that most people are familiar with. In terms of what you guys do at MK Machining, let's start with you, Tyler. This is Tyler Kemp, the owner of MK Machining. What does your job encompass on a day in and day out basis?
At this moment, making a lot of builds for a variety of industrial printing technologies and generally quoting jobs for clients, along with meeting with the retail crew over new products, new designs, etc. And then assessing how parts for other clients are turning out as well.
You also do quite a bit of innovating and dreaming, as far as I understand, looking at new technologies, applying those new technologies. Some of the stuff that you showed me at the SHOT Show was just absolutely mind blowing, like those full color bottles and that sort of thing.
Yeah, so we've done a good job at staying at the forefront of printing technology, I think. The company was started back when I was an undergrad, almost 10 years ago now. I think in 2 weeks is our 10-year anniversary. And anyways, staying at the forefront of printing has always been what has led to success for us a long time ago. That was learning how to dial in nylon on consumer grade FDM machines, and now it's kind of the same thing, but much more expensive machines.
Yeah. Okay, and then Tony, thank you for joining us as well. Tony's the sort of brand manager, one of the public facing guys. When did you join MK Machining and kind of what is entailed in your work?
Yeah, so I started with MK Machining. It was about middle of 2021, so I've been here for a few years now. I'm kind of the boots on the ground guy, so I get out and I travel out to matches, and I shake hands and meet with a lot of people. And what do you like about our product so far? What do you not like about them? What can we do better? What kind of cool stuff we can do to innovate and keep bringing cool stuff to the market. And then I handle a few dealers and other high end sales like that too. So
Gotcha. I got to say, what you guys do is certainly exciting. Myself being a mechanical engineer, if you can imagine it, you can build it. And this new technology is just amazing. Why don't we jump right into this nylon 11 that you guys use and the HP machines that are capable of such amazing capabilities. I'll start by saying my only experience with 3D printing is FDM, right? And FDM is like a robotic glue gun, essentially. I've used PLA, I've used PETG, and it's really great for just odds and ends and playing around. But the equipment that you guys have is in a completely different stratosphere. Tell me about this technology.
Yeah, so we have 5 MJF 5210 Pros until super recently. Those were the absolute top of the line units. There's basically a new software upgrade that I think that's a 5460 or something that we'll probably move to. But anyways, MJF stands for multi-jet fusion. It's cool in that every layer takes the same amount of time, much say like a DLP printer that some folks might be familiar with, but beyond each layer taking the same amount of time, it's completely different. You're spreading out a layer of nylon or a nylon-like material, pretty much all polyamides. It's a powder bed fusion based technology. So SLS would be similar. This is a much faster version of SLS. So long story short, you're laying out your powder. Carriage is coming over and depositing agents that tells that powder where to melt. Everything is done in a chamber, very close to your melt temp, and these agents and some really bright lights basically set it over the edge. I imagine we'll probably splice in some B-roll. It's kind of a lot going on with these machines. A lot of sensors, a lot of monitoring, a lot of thermals that you have to manage, and it can make a lot of parts quickly. It can make a lot of money quickly as well, although the machines are quite expensive. But improperly used, you can throw away a lot of money quickly. Nylon 11 is our specialty material. We print more of that material than anywhere in the world. It is more robust than nylon 12, which is a lot more common. We print a lot of nylon 12 as well, but specifically 11 offers a little better surface quality, better tolerances, and its rigidity is about 95% that of nylon 12. So in the hand, you can't really tell a difference in that rigidity aspect. But you have about 10 times the elongation before you have a fracture. And so that leads to, something being able to deflect much further. Sometimes you can replace metals for specific applications. The strength is, nowhere near most metals, but that deflection before, permanent deformation is important. So we've done many, many, many night vision pods is a good example. You can get thin walls, a very light shape. They pass the mill drop test standards, whereas say a 6061 aluminum would not.
Yeah, you guys have the video of, I think it's scope throw levers in a vise hitting it with a hammer, and the thing's just getting whacked. And in mechanical engineering lingo, there's a big difference between strength and toughness, right? Toughness being the total energy required to fracture something versus the strength aspect of just how many pounds per square inch or whatever your units are. So that's amazing material.
Yeah, and I think as you talk about like that throw lever demo, sometimes ultimate strength isn't necessarily desired, and I think a throw lever is a good example of that. We've sold many of those throughout the years, hundreds of thousands, and I think a printed throw lever is a perfect application to show the usefulness of the technology for somebody at the super high end market. They don't want to scratch up the anodization on their tangent, or there's zero compromise, perhaps, and the nylon's not going to do that. At the other end of the spectrum, maybe they don't want to spend $75 for a machined lever to put on, I don't know, like their Bushnell Match Pro or something like that. So it kind of suits both ends of the market. And say you catch a barricade or a dump barrel in a 3-gun scenario really hard, you want that lever to give rather than your optic.
Yeah. Yeah, absolutely. The biggest thing that I noticed about the products that you guys print is that surface finish. I would liken it to like a micro texture. Sometimes a desired texture that's built into injection molds, and it looks polished, it looks finished, and if you don't look super closely, you absolutely would not know. Yeah, there's your logo, that it was 3D printed, and ultimately, you know, I I've got products in development. A lot of them are for gunsmiths and that sort of thing. I wouldn't want to sell something that looks, deliberately 3D printed, like one of our FDM, products where you can see all the little lines and that sort of thing. But when you can get a product that looks like a micro textured injection molded part, and you can do it in very small quantities, and you can customize. Now we're talking.
Yeah, and I would venture to say with proper part design and orientation, you couldn't tell it was printed at all. We can have some B-roll and stuff over it. The camera's just not gonna show everything we're after.
Right.
But if we stay away from about a 10-degree angle on the bottom side, you simply don't see layer lines, and you don't get a mold seam either.
Hmm. Let's talk about how part layout differs, right? Like when you're CNC machining parts, you typically use a tombstone. You have a bunch of blanks, little billets, and they get individually machined. And sometimes you'll have to flip them around and reclamp them, right? In specialty fixtures. Tell me about the build volume on these HP machines, and then you've shown me some renderings in 3D of how the parts are laid out. Talk a little bit about how you can optimize the build volume.
Yeah, so we're packing in a 3D chamber, rough dimensions, about 14 inches square that we can jam parts into. Um, Proper part orientation is super important for consistent results. So say whether it's our own retail products or products that we're making for a client, a big difference with us versus other service bureaus ultimately that could make parts, whether they're our own or yours, is we keep consistent orientations. For us, it's about maximum quality rather than minimum price. So I always tell,
Mhm.
potential customers if they want me to make parts, if absolute rock bottom price is your main desire, I'm not going to be your answer. But we will be competitive in quantity, and we'll give better quality than anyone anywhere. So in terms of part layout when printing, grips are a good example. You don't want to trap heat. So you could print this grip, this AK grip, in this fashion, but you're going to trap most of the heat from the hollow grip area inside, and then you can get what's called thermal bleed, which is almost melted powder that doesn't really come out. Maybe over
Mhm.
time it comes out. It basically like leaves a mess in your safe wraps. So bam, a grip you would want to print to allow the heat out. Proper part design also goes into this. So say like the bottom of this grip, if it had a very slight angle to it, you could see that stair stepping effect. So if you're designing a part, of course you could orient it slightly. Uh, but anyways, proper part design wouldn't have, say a 90-degree angle right here, and then another surface that's damn near parallel, but not quite, basically imperceptibly so. And then after you print it, you're like, ah, man, I can see that stair stepping.
Mhm.
There's, many other aspects of proper part design for MJF. It is a lot of the part design for injection molding. I'm happy to go in depth with a customer, if they have specific design needs.
Mhm. So if you were printing really small parts in that 14 by 14 build volume, how many is a realistic number for like a little clip for a wire or something like that? How many could you stack into there?
Probably 25,000 or so. Way back in the day, if people remember, COVID swabs, I think it like touches your cerebellum slightly, so about that length. You could get about 5,000 in a build,
Wow.
with throw levers. If you're really maxing it out, probably around 1,000, I would guess.
And how long would that run take to complete for like 1,000 throw levers, do you think?
Luckily, I don't think I know. So the jobs we generally run with nylon 11, for maximum quality, we run about a half height build. It's about a 7 hour print time. Then we run nylon 12 overnight, which we run full builds on. And that's about 14 hours with the specific machine settings that I prefer to run.
Gotcha. And can the machine repeat cycles without human intervention, or do you have to do some loading of the material or anything like that?
So the machines have carts that go in and out of them. The carts have a platform. Again, I'll give you a layman's explanation here, but we can overlay some B-roll, or folks can YouTube, or we have plenty of videos on our social media. But you have a cart that goes in. It's got a platform up top, and that surface basically is always going to be flat up top. But there's a fairly complex augering and vibratory powder transport system that has taken all the powder that's directly below this platform and bringing it up top as this platform drops down. So you still have the same height, but then your raw material that was below the platform is now above it, and your parts are suspended in this chamber and surrounded by powder that then you can recycle and reuse a certain proportion of that unfused powder. I think to answer your question, there is intervention required in between cycles. And then there's
Mhm.
varying degrees of how much intervention and maintenance will these operators offer in between cycles, which can really impact your part quality. You have
Mhm.
lamps and surfaces, thermal cameras, etc. That it's really important to clean in between runs. That might not be the cheapest way to operate the machines, but we try and go above and beyond in that aspect for repeatability purposes.
Mhm. So you're saying the price tag of this equipment is justified because it's not a simple coffee maker.
It is really expensive. Is it justified? That depends on if you're running your machines, day and night. 5200, which is your base hardware, that's in the $350,000 range, and that's a hard pill to swallow. But then to go to a 5210 is a significant fee above that, but your consumables become cheaper. And then to go to a 5210 Pro above that is yet another expensive charge that allows you to run what's called bulk material, in which you're getting your raw powder in what is essentially a gigantic Ziploc bag, vacuuming that via expensive vacuum system into 55-gallon drums, etc. Is the ultimate price tag, which is well north of $500,000, worth it if you're running every day and either you're selling your own parts or making parts for others, or in our case, both? Yeah, it's really worth it for us, but you better have a good use case scenario for the machines. And service is not cheap. Consumables are not cheap. Warranty's not cheap. Nothing industrial is, though, sadly.
Yeah, no, that makes total sense.
Tyler, to give people at home a better picture of how much maintenance that goes into it, how many maintenance and replacement parts do we keep on hand to keep these printers going?
I would guess several hundred. The machines are really complex when you have the panels off. Sometimes I would say too complex due to, I don't know, safeguards in place that may stop a job when it probably could have kept going. But other times it's great. There's been a very few rare instances where, say, something was left in the machine, a vacuum brush or I don't know, a bit from a screwdriver somehow fell out, and the machine was able to stop itself before it wrecked itself. But anyways, we have many, many, many replacement parts on hand, as well as the next day service plan.
That's awesome. It helps to hear more about some of these capabilities, the equipment, the consumables. It's not a simple space, but you guys have obviously really focused there and become experts. And to that end, what is a proud moment that you have where you came up with a design or solved a problem with one of these challenges? You mentioned one is, the heat buildup that you can get and the problems associated with that. Is there anything that specifically comes to mind as like one of those aha moments when you said, that was awesome. I figured it out. Or,
I mean, to be honest, kind of every day as we make parts, it's cool to see how it's grown from, literally an idea in a dorm room. And then, what was it? A Creator Pro, a Creator Pro 2, maybe was the FDM machine we started on. So every day it's kind of cool to see what has been built. But I really like, this is going to get outside of the firearms world, but personalized solutions, to problems. And I think a really good example of that is we're the manufacturer for an O&P company, that's orthotics and prosthetics, out of St. Louis, and they're able to scan folks' nubs or legs or feet for various purposes, and literally within days you can turn around a personalized solution that makes them mobile. And that's pretty cool because that's not how it used to be. And the economics of it are also wildly improved from what they used to be. So again, that's not a firearms related example, but it's one that I find really cool.
yeah, knowing someone that worked in a prosthetics lab and knowing a little bit about what that manual process is, with fiberglass and a lot of grinding and sanding and all that stuff, that sounds very purpose driven. That's really, really cool stuff.
Yeah. Another aspect that I find awesome is perhaps folks in years past who perhaps poo-pooed 3D printing, then come to us for quotes years later, or when they're using some of our prints on like a big name OEM rifle and don't know it. I think those things are neat when folks don't even know they're touching something printed.
Yeah, no, that's awesome. And you guys are very well known for your work in polymers, but your overall portfolio of manufacturing extends well beyond that. Let's talk briefly about the Bullpup and how there are CNC machined aluminum parts there. You guys get into a bit of the additive metal stuff. So it's not just polymer.
Yeah, so the impetus for starting MK Machining was this bullpup. So as an undergrad, I was doing the marketing for GA Precision. I know George well. Precision rifle has been my passion for a long time. When I was working at GA Precision, Desert Tech came out the SRS. I think that's a neat platform. And back then, I think it was Desert Tactical Arms, actually. Uh, and I remember George saying it's a bullpup. The trigger's got to suck. The Gen 1, it's been much improved since the Gen 1s, but even the Gen 1 SRS had a pretty good trigger for a bullpup. I wanted to make something a consumer could drop their firearm into instead of it being a totally bespoke solution. So this is our Mark 2.6. We've got a Curtis Custom edition of action. It's really just a customized bolt to bring that bolt forward. That's just an option. But the chassis was the impetus for starting MK Machining. Uh, Despite the name, we don't do any subtractive work in-house at this second. We used to, and I started printing originally, again, as an undergrad in a dorm room to raise funds for a local machine shop to make our very first protos of the chassis. And I should have had one of the old chassis in here to show you. We'll get some pictures so it can be overlaid. It's pretty rough looking, but it was still cool as a college kid back then. And the printing really took off. Throw levers were one of the very first products. That was a brainchild, I guess. It's so simple, but its simplicity and the customization you can do with printing. I mean, again, we've made hundreds of thousands of them. But one printer led to two, led to four, etc. We for years had the subtractive and additive side side by side. And then as I saw specifically the 5200 series of MJF machines about to come out. We got one of the very first in the country. There was a 4200 series before, but at that time, it was kind of our first big leap into industrial tech. It was, do we want to get into several nice CNC machines or a really nice 5-axis or a really nice printer, which is, for me, it was an easy decision, and I'm glad I made that decision. I don't plan on getting back into production subtractive work for others in-house. I do think we will bring it back for our own internal purposes. But yeah, so let's talk about the bullpup for a second. Typically, bullpups have core triggers. The very first prototype we ever made, it wasn't nearly as refined as this, but it had a good trigger. And the heart of that is a rigid linkage. You know, if you have a good trigger, which Timney makes an OEM trigger for us that's customized, you have a good trigger and a rigid linkage, you should, you know, have a good trigger from there. So this is probably set up, I don't know, maybe 8 ounces. The trigger is nice and crisp. I think the customer will be able to see that.
Mhm. And then, yeah, good trigger. Once you use a good trigger, there's really no going back,
Yeah.
you know?
And then what's a good trigger with a bullpup? You know, if your safety's still back here, so there's another linkage system dedicated for the safety. That's not just blocking this forward trigger; it's actuating the actual safety on the Timney unit. So this is a, you know, all in all a niche product. I don't think I ever thought it would be anything other than a cool niche product. But it balances really nicely. You can see with the can on here, and I think this is a 22-inch barrel. It's still quite compact. And again, the balance is nice. Takes AI mags, 700 short action, 700 long action. We have a Tika short action, and then we're revising a Tika long action. It needs to take medium length magazines. But anyways, it's super cool to me. Some folks are not interested in a bullpup bolt gun, but it's really awesome in a stand. It's
Mhm.
That's all I can say. It's really awesome in a stand. It's super short. It's super balanced. It's good for killing stuff.
and we are planning on showing this on the channel. I'm really excited about this. So we'll get to back to that in a bit. I think your move was really good to focus on 3D printing because you guys have really focused there and you've really innovated there. There's so many people that do subtractive machining, the entire industry essentially. So for you to come in and say, we're going to get really good at this and we're going to gear up for this and not only the manufacturing side, but on the design and DFM, right? Design for manufacturing, right? I think it's really good to have that level of focus and expertise.
Yeah, and I'm glad we made that decision as well. I think an extreme example. Well, I'll give a less extreme example. So as I was deciding, can I really drop like this amount of money on a new machine? Well, you better have a good business case scenario for that. But as I was comparing versus expensive subtractive equipment, in the US, there's machine shops that, they've been around 100 years. How are you going to compete with that level of capital? Or my extreme example, I got a private tour of the Beretta facility in North Italy a few years ago after Iwa. And there you can see, I mean, you're talking like 700 years of repeated investment. And they had the most impressive subtractive facility I have ever seen, but my printing facility is 10 times what theirs is.
Mhm.
And again, they're a massive company, and beyond that, there's not really a comparison. Uh, but we have one of the most extensive additive spots in the country, which is pretty cool. And a lot of it is in a pole barn in my backyard.
Yeah, that's a true success story. So let's talk about metal additive.
Yeah. So there's two main methods to go about that. There's binder jet, which is a lot like metal injection molding in terms of its part properties and the pluses and minuses of that. We have a binder jet machine. I don't like it much, so we're not going to focus on that. We're going to focus on DMLS, which is a powder bed fusion based technology. So you're going to get parts off it that are full strength out of the machine. There's a variety of
Wow.
materials you can run. This is kind of a hypothetical, cool, at least in my mind, suppressor design. I'm sure it worked reasonably well, but it was made to show the complexities that you can offer off a DMLS machine. So we have multiple machines running 17.4 stainless right now. We have a TI-64 setup inbound, and then we have an Inconel 718 setup waiting to get hooked up. We have a second facility almost done at this location. And then our metal area will get much larger, and I can't wait to show you that in person. But what would you like to know about the metal printing side of things?
Yeah, well, you described the process with the HP machines and the 911 polymer process. So is this like a triangulation of lasers that center the metal and fuse it? How does that work exactly?
So there are multiple laser machines, and I think they're getting better and better at that triangulation aspect, but you better have like
Mhm.
spot on calibration. And even multi laser machines that are in the millions of dollar range, typically you're not crossing that laser field. You would use them as essentially multiple machines in one. We do not have a multi-laser machine right now. I do think
Mm.
we'll wind up with that. But regardless, it's a powder bed fusion based technology. Where it is similar to MJF is that you have a recoder laying out a layer of powder. But beyond that, things are different. So you have a purged environment, or at least most industrial machines do. So you need to get oxygen out of there so you don't get
Mhm.
oxidizing a material. You don't get smoking, which will occlude the laser. So
Yeah.
ultimately, it's actually a lot more simple than the MJF machines. If you see everything with the panels off, they're both pretty complex, but the MJFs, they got a lot going on. You're laying out a layer of powder, you've evacuated the oxygen from the environment, and then a laser is melting that.
Gotcha.
The DMLS machines, much like your FDM machine, they run off G code, which is kind of cool. So you have a lot of parameters you can control. Typically, with the more industrial machines, the manufacturers will have like release parameters where it's like we guarantee these performance properties if you use these parameters, and you can get really durable parts. You're talking densities in like the high 90s of percentages. Again, depending how fast you run the laser. If a customer could get away with 90% part density, you could probably print twice as fast. But anyway, so you're getting really good part density, minimal porosity. You have a camera that's watching everything. And for arrow work, that's important. Something fails a few years down the road, you need to be able to confirm, was it an issue on your end? Um,
Right.
yeah, yeah. And your material properties are quite good. 17.4, you can heat treat after that. Any of the materials you can heat treat. But due to the nature of the process, it's somewhat treated already. Titanium, its material properties when BMLS are superior to raw stock, which is really cool. I'm not a metallurgist, but you can look that up. There's a lot of papers on that by metallurgists.
That's amazing.
Yeah. So the downside to DMLS is machine time is expensive. The machines are expensive, hence the machine time being expensive. Your material is expensive, and your parts are welded to the bed. So with optimal part design, the only surface with supports is against the bed, and then you can EDM that off, or you can bandsaw it off and process from there. And that's really where it's at for production parts. You can do prototypes of parts that you plan to process in a subtractive manner. But that would be for prototypes only. Essentially, you have a dichotomy at the beginning of your design process. Am I going to design for subtractive? If so, that is directly opposed to what's optimal for designing for additive. Some parts aren't going to be perfect for printing. I think many folks in the industrial additive space are not entirely honest with customers all the time. Like, printing is not going to take over every type of manufacturing. It is going to disrupt, some subtractive processes, but not all. Conventional manufacturing is not going anywhere, but it will be supplemented by additive for sure.
Yeah. Very cool. So do you want to talk about any of the actual products that you're bringing to market with additive metal?
Yeah, yeah. So right now we're OEMing for others exclusively, but not for long. We're making parts for our Bullpup, the Mark 2.6. We have another cool Bullpup project that I'm hoping to debut at SHOT 2026. That it will use DMLS parts in conjunction with subtractive parts. We will certainly be coming out with our own line of suppressors, but it's really important for me. We got into the DMLS space because of some of our customers. So I've been, very upfront with them that we will, utilize this technology for our own parts, but those customers come first. So that's really important to me. When we will have our own line of suppressors, that is completely tentative based upon what our OEM customers want. But that will be coming. We'll be having breaks as well.
Cool.
Yeah, we posted these on our socials the other day. These are, I would say, some geometric torture tests. You can see they turn out pretty dang clean. I wanted something you couldn't manufacture conventionally. But
Yeah.
what I envision is kind of a suite of self-timing breaks with widely varying aesthetic and directed performance goals, kind of. And we can do a lot of different parts without a lot of fixturing and tooling required. So I don't have a specific date on these either. Again, we're busy making parts for other folks, but I would estimate end of this year, early next for brakes and suppressors sometime next year.
That's awesome. And of course, we'll be a part of that following ongoing discussion and bring you all updates as we get them. And I have that metal lathe accessory, the tailstock DRL bracket that you guys printed for me, and I'll be showing that on one of my future videos. Really exciting to be able to do limited quantities, super high quality, production ready, customer ready parts like that. And yeah, I'm looking forward to seeing what you guys do next. So I just want to emphasize, if you're interested in MK Machining, whether you want to buy parts that they manufacture or work with them to help you manufacture stuff, go to mkmachining.com. Scroll all the way down to the bottom, and there's a few different ways that they can contact you all. And I really want to thank you guys for the time today. I actually learned a lot. This is really exciting. I graduated with a mechanical engineering degree in the year 2000. 3D printing was very, very, very much in its infancy at that point, like you said, for prototyping only. And to see over this 25 years how far things have progressed, how quickly, is just super, super exciting. So hopefully we've busted a few of the sort of stereotypes or inhibitions around 3D printed products. It's not the fact that they're 3D printed, it's what kind of 3D printing is utilized, what kind of materials, and ultimately what kind of design and manufacturing, is performed and conducted. And you guys have certainly shown that there's a whole variety of products within and outside of the firearms industry that are great candidates for this kind of work.
Yeah, and you had touched on a process very briefly. I think it was like 4 words, previously. You talked about our full color printing, and I wanna show that really quick, because perhaps it'll give folks ideas. Everything we've talked about thus far, is like hard use end product, either prototypes or production pieces. We have a machine, its process is called 3D 3D ultraviolet jetting, and it creates photorealistic and color accurate. And when I say color accurate, like to the specific Pantone number, um,
Wow.
as well as clear. And so in the firearms world, this is a pretty niche application. But if you have a really cool showpiece that you want to show the function, you can totally do that with like a cross section view. You can do extremely accurate details. This is for the local university, and it's a super
Wow.
neat technology. This is called 3D UJ. Again, it's not for hard use products. Could you make a crazy grip and it survived for a long time? Yeah. But it's a completely different vein of printing than we've talked about thus far, and a lot of folks aren't aware that something like this exists. So, anyways,
Mhm.
I wanted to make sure we didn't forget that.
No, that's cool, especially to show at the very end here. Okay, so if you guys have questions for the MK Machining team, uh, whether it be Tony or Tyler, drop those in the comments section and we'll join you there and further the discussion that we had here. Thanks again, guys, for the time. Really appreciate it. Looking forward to working with you guys on a number of projects over the years. So that's it for that video. That concludes this video, and that means it's time to wrap it up. I hope you enjoyed this video. If you're watching Ultimate Reloader on TV and want to take advantage of free resources, exclusives, and hot deals, just hold your camera phone up to the QR code, tap on the link, fill out the information, boom, you're getting Ultimate Reloader emails. Don't forget to like and subscribe. Also, we're on Facebook, YouTube, Rumble, where we've got unrestricted content, and Instagram. Make sure to follow us on all those channels. Ultimate Reloader also has a commercial solutions division serving law enforcement, the military, and the gun industry. We have some unique capabilities, including a comprehensive suite of recoil testing and evaluation capabilities, trigger profiling, and more. Thanks again for watching.